For the third day on our unit with radicals, we are going to talk about rationalizing denominators. One of the things that you want to make sure that you're always looking for is whether or not there's a radical in the denominator of your fraction. If a fraction has a radical in the denominator, it is not considered to be simplified. So it's not simplified if there is a radical in the denominator. If we are going to rationalize the denominator of a fraction, what that means is that we are going to find an equivalent fraction in which the denominator has a rational number in it. If we are rationalizing denominators, one of the things that we want to make sure that we're conscious of is whether or not our denominator is a monomial or a binomial. So if you take a look, we have at the top here steps for rationalizing when the denominator is monomial, and in the bottom of the paper when it's a binomial denominator. So for the first four examples, it's a monomial denominator because we only have one term in the denominator of the fraction. And step number one says we're going to multiply the numerator and denominator of the fraction by the radical that you see in the denominator. So if we take a look at example number one, I can see that I have a radical 5 in the denominator, and that is illegal. So I'm going to multiply by that radical top and bottom. So I have a radical 5 in the bottom. I multiply the bottom by radical 5, therefore the top, which gives me 2 radical 5 on top. And on the bottom, I really have radical 25, which we know is just 5. So this answer is considered simplified, a simplified form of what we originally started with. Technically, the two that are squared off in yellow are equal to each other. If you type them into the calculator, they have the same exact value. This second one, our final answer, is the preferred one because it's considered simplified. There is no radical in the denominator anymore. If I apply that same idea over to question number 2, in question number 2, I can see that I have a radical 18. One of my options is to multiply both top and bottom of this fraction by radical 18, but in this case, I'm going to take a little shortcut because I know that if I multiply 18 by 2, I get 36, and 36 is a perfect square. So I could multiply by radical 18 over radical 18, or I can take a little shortcut if I know my math facts and just multiply by radical 2. Either way, you get the same answer. It's just that if you multiply by a smaller radical, your answer is a little shorter in the end when you go back to kind of clean things up and reduce. Square root of 36 is 6, and we have one more step here where we go back and reduce. So I end up with 2 radical 2 over 3 as my final answer. In question number 3, I have a radical 3x as the radical that's in the denominator, and we know that that's illegal to have a radical there. The 2 that's there is totally fine though, so I'm not concerned with the fact that the 2's there, but I don't want that radical 3x there, so I'm going to multiply both top and bottom by radical 3x. So I have 3 radical 3x over 2 times, and when I multiply these 2 radical 3x's together, I get radical 9x squared, which is just 3x. When I get to here, I can go back and cancel out the 3 on top and the 3 on bottom, and I end up with radical 3x on top and 2x on the bottom as my final answer. For question number 4, in this case, I have 4 radical 8 on the bottom. The 4 is fine where it is. It's not under a radical, but I have a problem with the radical 8 being there. The fraction is not considered simplified if there's a radical in the denominator. I could multiply by radical 8, but I do know that there's a little shortcut here. If I multiply by radical 2, 8 times 2 gives me 16. So this is going to be 4 times, this is radical 16, so 4. And on the top, I have 3 times radical 100, which is 10. So at this point, I can go through and get 30 over 16, which reduces to 15 over 8 when I divide by 2. So that's my final answer. If we go on to the second part of the notes for rationalizing denominators, what's going to happen on these is that you will have a binomial in the denominator of your fraction. Before we can actually go through the whole entire process with these, we need to talk for a minute about a vocabulary word that's called the conjugate. Our steps to rationalize a binomial denominator are that we are going to multiply the numerator and denominator of the fraction by something called the conjugate. And before you can actually do this process, we need to take a couple of examples here and see what a conjugate is. So for question number 1, it's saying find the conjugate of each of the following. You can see that each of the terms are binomials, and to find the conjugate of each of these, what you do is you change the middle sign, only the middle one. So it's -1 minus radical 7. Easy as that. Number 2 is going to be 2 plus radical 3. Number 3, 17 minus 5 radical 2. And then D, -5 plus 9 radical 10. So the only thing we're doing on every single one of these is changing that middle sign. Question 2 is asking for us to do something with the conjugate. And in this case, it's saying that we are going to find the product of this number and its conjugate. So when I go through and I multiply this number by its conjugate, which is 10 minus radical 5, I can see I have two binomials that I have to multiply because of the word conjugate, and that means I'm going to have to FOIL. So when I go through and FOIL this out, I have 100 minus 10 radical 5 plus 10 radical 5 minus radical 25, which is just 5. So this is radical 25, which I just made 5. One of the things about multiplying conjugates together is that when you multiply your outer and your inner together and you get these two terms, if your parentheses contain conjugates, these two cancel out. -10 radical 5 plus 10 radical 5 cancels out. So when that happens and those cancel, I'm basically left with 100 minus 5, which gives me 95 as that answer. Essentially what happens on this is we start with something that has a radical in it over here, multiply it by its conjugate, and end up with something that doesn't have a radical. That idea is what we're going to use to simplify and rationalize fractions that have binomials that contain radicals in the denominator. So when we take a look at what we have on question number 3, I can see that my denominator does have a radical and it is a binomial. So that being said, I want to go in here now and use the process that we talked about. I'm going to multiply by the conjugate. And if I do that in the denominator, I have to multiply that same thing in the numerator. Remember, when you multiply conjugates together, you should go through and do FOIL, but remember the outers and the inners cancel? So we only have to do the first times the first. So if I take a look at that, that's 4 times 4, which is 16, minus radical 5 times radical 5, which gives me radical 25, which we know is just 5. On the top, I'll distribute 36 minus 9 radical 5. When I get to this point, I want to go back and clean that up a little bit, make it a little more organized. So I will have 36 minus 9 radical 5 over 16 minus 5, which is 11. And that is my final answer. You always want to check and see if you can reduce anything. Sometimes you can do some more reducing, but not in this case. For part B, I'm going to go in and multiply again by the conjugate. I have to multiply by the conjugate because there's a binomial in the denominator. My conjugate is 3 plus radical 5, so I'm multiplying that in top and bottom. Distribute on the top. On the bottom, I'm going to do first times first and last times last. So 3 times 3 is 9, minus radical 25, which is 5. So this is 6 plus 2 radical 5 over 4. And when we get to this point, we are looking at going through and reducing. And we talked previously about how if you have two terms on the top and one on the bottom, you need to split that up so that you can go through and reduce. Now, in this case, I'm going to show you a little shortcut to make your life a little bit easier right here. And what I'm going to do is I'm going to talk about how you can take a look at all three numbers, not the one under the radical, and see if there's anything that goes into all three of them. In this case, 2 goes into all of them. It goes into 6 3 times, into 2 once, and into 4 twice. And when I go through and do that, it leaves me with 3 plus radical 5, or 1 radical 5, over 2. For question 3D, I'm going to skip C for 3D. I'm going to multiply also by the conjugate when I go through and do that. So for the conjugate, when I multiply, I'm going to multiply by 2 minus radical 2, both top and bottom. And in this case, because the top is already a binomial, I'm going to have to go through and FOIL on the top. So I go through and do all the foiling. So this is 6 minus 3 radical 2 plus 2 radical 3 minus radical 6 when I go through and FOIL that out. And on the bottom, just first and last because they're conjugates, so this is 4 minus 2. When I go back now, take a look at what my final answer is. On the top, I have 4 terms that are all unlike. So I cannot do anything about combining those 4 terms together. The bottom, though, I can simplify just into a 2, and that becomes my final answer. For question 3F, they're asking for us to find the multiplicative inverse. Multiplicative inverse you've been using for years. The multiplicative inverse is technically the reciprocal. So if you were looking for the multiplicative inverse of, let's say, 3, it would be 1/3. So you put 1 over that number. So if I'm looking for the multiplicative inverse of this, I'm going to do 1 over that number. And then based on what you know you cannot leave a radical in the denominator. I have a binomial denominator, so I'm going to have to multiply by its conjugate. On the top, I will end up with 6 plus 3 radical 2. On the bottom, first times first, last times last, which is minus 9 times 2. So this gives me 6 plus 3 radical 2 on the top, and 36 minus 18 on the bottom. If I move along a little further and reduce that now, that gives me 6 plus 3 radical 2 on the top, and 18 on the bottom. And if we use our little shortcut for dividing and reducing, we can go in here now and say, if I look at all 3 numbers that are not under the radical, if they can all be divided by something, I'm going to do that dividing. I can divide 6 by 3, 3 by 3, and 18 by 3, which gives me a final answer of 2 plus radical 2 over 6.